Welcome back to another unscripted devlog. I'm going to be answering your questions from the last devlog, so thanks for asking questions, you guys. Keep the questions coming. I'm going to answer them to the best of my ability, so hopefully the information you get here can be somewhat useful to you. So for example, somebody asked, how does the camera work for this little character selection area here? And I kind of changed it a little bit from the last video, so if I actually, if we go back, let me go to the Guardians menu. So my camera goes to it. I kind of tilt the camera around a little bit, and then I switched up with buttons instead this time. I had some feedback where having to walk up to different areas was kind of annoying, so having some quick access UI to, you know, access some things was a little bit better. But basically how this is working is with springs. So I set a target position for the camera to go to, and then I use a spring module to have the camera animate to the position or the target of where it needs to go every single frame. And we'll check out that script here in just a second. But then, of course, with my mouse, I move my mouse around and my camera slightly rotates to look at where my mouse is at. So if we take a look at the code here that's responsible for it, when I enter into the character menu, we enable the GUI. I clean up the camera trove just to make sure there's nothing else in there that shouldn't be in there that hasn't been cleaned up previously. But basically we have a positional spring and a rotational spring, and we need to set the target position. Well, currently we set the target position to where the camera is at currently, so that way the spring is matching what the camera's current position is, so that way we can tween or basically interpolate the camera smoothly from its current position to where we want it to go. And where we want it to go is where we calculate it inside of here every single render step. So we set the camera type to scriptable, and then we need to do some math in here, which basically we get the field of view of the camera. We need to get its viewport size to get the aspect ratio, and then we have this neat function here called get camera aligned bounding box. We'll go to this function. I'm not going to act like I know the math to this fully. I had some help with ChatGPT, which I'm really surprised. ChatGPT is kind of getting quite smart figuring out how to calculate a camera aligned bounding box. But you can basically imagine this, how if we go actually into the game, and maybe if I can open, if I go to studio settings, there should be a bounding, show bounding boxes. This is like a basic example I gave. So as you can see, objects in a game have bounding boxes. As you can see, my model has this bounding box that changes in size when I jump and I have my animations. But you can see that the rotation doesn't change. This bounding box is remaining with the global coordinates or the global rotation of the world. Now, you can also have bounding boxes that match the local axes of some kind of model or a part. And then you can also have camera aligned bounding boxes where the rotation of this bounding box actually matches the camera's rotation. And because the bounding box has to match the camera's rotation, then it needs to calculate what the bounding box would be to contain everything in a part or a model. And that's what this function calculates. You get the instance, which is going to be a part or a model. It does a whole bunch of math, and then basically it's just going to return to you what the position or the C-frame is for this box, and then the extents of it. And then we get that size, this vector3 value, and we take this size and we throw it into this function, which I have fit camera align bounding box to camera. And what this is going to return is a distance in studs of how far away the camera needs to be from said object that we gave it, which is the adornee of the UI. So the adornee is going to be this part here or this part here, depending on what you're looking at. So right now we're looking at this part, it's this adornee, or we look at this part, it's this adornee. And that's being passed to this function. We get the size of the bounding box, and then we pass it to this function here, which takes in the current field of view of the camera, current aspect ratio, and then I add a little bit of padding. So that way the edges of this part is not like right up against the screen edge, just a little bit of padding, so it makes it look a little bit nicer. And then if we hop to this function, basically given the camera aligned bounding box of an object, calculates how far back to move the camera. So we get in radians, we convert the camera field of view into radians, compute horizontal field of view based on the aspect ratio. So we're jumping into some trigonometry here. Again, I'm not going to explain the math to you. I mean, you can see the code right here. Basically, it works. That's what this does. This works, and we get a proper distance that we need to position the camera away from the part to have the entire part's camera aligned bounding box within the camera's viewport. Pretty cool math. So we do all these calculations, and then also here is where the camera rotation comes into play. I get the current mouse position on the screen from the viewport center. I divide it by some constant so that way I can reduce how much moving the mouse rotates the camera by. And then we get our basic base C-frame, which is our goal position, which is going to be the Adorni's position. And then we offset it by the distance away we need to have the camera from that part, which is just, we get the look vector of this part, which is, the look vectors is this Adorni facing me. We position the camera away based on this distance given by these functions here. And then this is going to be our goal position. So the base C-frame is, we're going to take the camera. We want it to look at goal position from current Adorni.position, and the up axis is obviously the y-axis. So from goal position, we're looking at our Adorni, y-axis is up, and then we get the rotation delta here from the offset that we calculated right here. We just get the y and the x, and then I reduced the rotation on the x a little bit, which is why I multiplied by 0.75. And then I'm literally interpolating this to a C-frame of nothing or no rotation, and I'm going like 95% of the way there. Again, this is just me reducing the overall rotation, doesn't really matter. We just add these C-frames together to get our goal C-frame, and then we need to store that as a target in our position spring and our rotation spring. So we get the position of our goal C-frame, there we go, that's the target for this. And then we need to store the rotation of the C-frame, so we convert the X, Y, and Z rotation using 2 orientation, and we just store it as a vector 3. That's what this represents. And then down here is where we reconstruct it. So we get the rotation from camera, rotation spring, grab the position value. It represents the rotation. And then we also have the positional spring. We grab the current position. So this represents what the spring is currently at. So we get the current spring position, and then we get the current spring rotation. We reconstruct the C-frame, and then that's what we set the camera C-frame to. So this is the magical math behind how this works. Yeah, it's a lot of work for a little feature like this, but hey, it looks cool, right? I probably didn't explain that well, but you can see the code. There's also, some other new stuff here, like I got a shop menu now, kind of same principle being applied here with the other UI that we're looking at. Instead, the focus point is, now we're over here, and I'm just rotating the camera around. Next question we had in the comments was, how do we name and organize module scripts? And I'm going to tell you, there's really no right or wrong way to do it. As long as you're organizing it pretty okay and you know where everything's at, that's really what matters for the most part. So as you know, I use my module loader to run the game. I have this server script that is given a bunch of containers, and these are going to be all of my quote-unquote custom services that this module loader is going to require. And then if these services have an initialize function or an init function, it calls the init function. And then if any of them have a start function, it calls the start function. And then of course I can add attributes onto the module to change the priority of when they get initialized and ran and all that kind of stuff. But that happens on the server side, and then it also happens on the client side. So if we go down here, here's our client script. Literally does the exact same thing. We give it some containers of where it needs to require and run module scripts. So the 3 containers are going to be the script itself. The modules in here are basically modules that aren't going to be required anywhere, which is why I preface the name with an underscore, because when I'm using my plugin, require autocomplete, and I want to get some kind of module or something, I can basically ignore all the ones with the underscore because I know I shouldn't really be requiring them from anywhere. All these modules are just setup module, which is why I put setup in the name. Some of these handle UI interfaces. Some of these just set up certain things like client settings or whatever. That's all these setup things do, and that exists on both server side and the client side. And then any modules that act as custom services that I can require anywhere in my scripts, I store them in a couple places. So obviously there's going to be server side services. That's going to be things like my anti-cheat service, my data service, I have a thing for cosmetics, some other stuff in here. These are going to be server-only services, so that's why they're in ServerScript service. And then any other services that can be required by either client scripts, local scripts, or server scripts, I throw them into replicated storage. So I have modules in here. Again, how you organize this is really up to you. I don't have my folders nested too deep. I just kind of make generic categories like client here for modules. This is where all my client-sided module stuff is at. So like I have client-sided services here, like handling blur on the screen, footsteps, spectating, that kind of stuff. And then I have shared services down here. These are services that can be used by either client or server, because you can see I pass the container to my module loader on my local script and my server script. And this is stuff that needs to be run by both client and server. And because I know that these modules are going to be required by both client and server, I require the run service in here. And then obviously you can see in my initialize function, I'm checking if this module is being initialized on the server or the client. So if it's the client, then I set up client specific functionality. If it's the server, I set up my server specific functionality. And the cool thing about this is that because this is one self-contained module that basically has everything in it, including like all the remotes and stuff, everything's happening in this one module. It's nice and organized. I can access everything. Obviously, you don't have to set it up this way. You could split stuff up into different modules, do whatever you want. Like I said, there's really no right or wrong way to do it. But as long as you just kind of utilize folders, not too crazily, but you kind of organize stuff where you think it makes sense for it to go, then great. It's basically all you need to do. There's no really right or wrong way to do it. Have clear names for what things are. Anything that you shouldn't really be requiring anywhere, if you use the require autocomplete plugin, you can prefix the names with an underscore, but you don't have to do that. It's just what I do. Now, a lot of you ask questions relating to the AI in the game. How does the state machine work? How is the enemy AI set up? How does the pathfinding work? That kind of stuff. And it's controlled by a state machine. So go to replicated storage, I go to my modules, I go to my client, classes. I should have a state machine class somewhere. I might have moved it, so this is why we use search. State machine class. Here we go. State machine class. This is not my own state machine class. I mean, it's a modified version of a state machine I found on YouTube. I'll link it in the description so you can find it. But basically, the idea with a state machine is you have states and you have transitions between those states. So when you enter into a state, you need to have these transitions, which are basically just conditions that get checked every so often that determine whether or not you can transition into a different state. And this allows you to code pretty good logic for your AI. And your AI can only be in a single state at a time. And it's just going to sit there and constantly run checks. You can determine, or I modified my state machine class to be able to determine how frequently I check states or I update states and how frequently I check transitions. So if I don't want to check a transition every single frame, I can instead have it be throttled and be only checked maybe 5 times per second or something like that. Now, I did move all of my AI to be controlled by the server now. And in the beta of this game, I'm going to change up the replication for them, because currently they're just assemblies automatically being replicated through Roblox's default replication system. But that's kind of inefficient. And if I want to be able to compact as much data down as possible and reduce bandwidth as much as possible, I found out that you can actually put objects within the camera in the workspace on the server side, because the camera instance is not replicated. So you can put assemblies, unanchored part, whatever, inside of the camera on the server side, and the server will calculate all the physics. But those parts never get replicated to any clients in the game, which means you can make your own custom replication, which is pretty cool. So I have a folder here for AI in my game, types, because I like using type annotation, but I have all my controllers in here. This is going to be for each enemy I have in my game. So let's take a look as an example at the noob. And let's go down here. Basically what this needs to do is it needs to return this thing that matches this type here. If I go to this type, it's going to have properties for the AI. I can add and remove whatever properties I want in here, as well as the agent properties for when it needs to pathfind. All that stuff is stored in here. And then it simply has a start function. And I just call this start function. I give it the enemy AI object. So I have an entity AI class here that this has a bunch of useful stuff to make it a little bit faster for me to code my AI. But this AI object just basically serves as a data container to store what the target is for the AI. So I can set a target, I can get the target, I can set it when it's active, and this is what, you know, calls that start function I was talking about and initiates like the state machine and whatnot. So I start it, I get the info, which is that info being stored in here, and then I call the start function. This returns to me the trove. This is just for cleaning up purposes when I want to stop the AI or the AI dies or whatever, and I have the state machine here too. And basically the state machine just starts running. So if I go back down here to my start function, what I do here is I get the model, I just call it the unit for the AI. I make the skills for the AI, specifically my noob just has a punching skill. And then I just start the logic here. So this is the targeting logic for my AI. Here you can see I have my trove here. I just add this loop to it. So while my object is active, I'm just constantly checking every single whatever this update is. So 4 times a second, I am getting the nearest target inside of my AI object utility function. So this function, if we go to it, basically what it does, goes through all the players in the game, make sure that the player's actually alive and they have an entity and whatnot, does some site checking stuff, and then if they are good to go, we're close to them, then we return that target. And because we get a new target, then we go and set the target down here if there's a new target. And then I also update whether or not the target was last seen if I ever need that information, whatever. Very basic while loop for getting the target. And then we have another one down here when I, what do I do? So I get, I have universal states that all my entities have. Like, for example, all the AI in my game can be stunned, right? So I don't want to have to like copy and paste the same stun animation or stun states everywhere. So I have a folder of my universal states, and then I just kind of copy these and put them inside of each individual AI on runtime. I construct my state machine down here using my trove, so that way the state machine can get properly cleaned up when the AI is killed or whatever. And then we return that state machine. I'm pretty sure my entity AI class is what activates the state machine. There's a lot of code. I don't memorize all of this stuff because like once you write it, sometimes you just forget it if you never visit your code back in a while. So let me see. I get my state machine here. State machine. Listening to the state machine. No, I think maybe the state machine just automatically starts in here. I think actually when you construct it is when it starts. That's going to be what my assumption is. So this is the default state it goes into when the AI first spawns. It's going to be in the wander state. So let's actually go to that state so you can take a look at what's going on. We have a wander state here, and this wander state has some transitions. Specifically, there's 2 transitions. There's a transition group here where basically 2 of these individual transitions need to be true to be able to go to the target state of this specific transition group. In this case, if both of these transition conditions evaluate to true, then the target state is going to be going into chase. So basically, we have a target, we can see the target, we're going to chase after that person. And then we have another one down here. If we only have a target, but we can't see the target, then we're going to wander to the target instead. Now, you might be wondering what's up with the 2 different target things here and why am I cloning them? Basically, I'm cloning these different states because sometimes I may reuse a transition multiple different times for multiple different things. So like, for example, this transition's being put in this transition group, and this target state is specifically the chase state. But for this one, I'm changing the target state to wander to target. And to make sure these are not interfering with each other, I just clone them. That's built into the state machine class. So if we actually go back to state machine class, wherever that was, state machine class, let's go back down here. We have, we can construct states, we can construct transitions and transition groups. So if I have a transition, I want to be able to clone the transition if I reuse it. So let me find the clone function. Yeah, it just basically deep copies itself and makes a copy of the object, which is useful when you're reusing transitions or whatever. And that's basically just what we're doing here. So we have functions in here of what happens when we enter into the state. Obviously, we're going to immediately start wandering here. And basically, I just have a default wandering function that performs that. And I just store that thread. And we're just updating this state. So if we ever stop wandering, so if the thread here is not active, then we're going to start a new one. If we exit, if we're currently wandering, we're going to cancel that thread. So that allows us to stop wandering and prepare for the next state that we're going to go into. So for example, let's say we're going to go into the chase state. So we're going to go into the chase state, and then obviously this one's going to have some different transitions here. So the transitions for this one is we have a transition group where we have a target, but we can't see the target. We lost the target, and if both of these evaluated false, then if the target is in the attack range, then we're obviously going to go into the attack state. And this particular state updates 3 times per second, which basically just indicates how often that on update function gets called. So if we go back to the Wanderer, I believe this one, 3 times a second. This on update function is being called 3 times every second. I can of course change that to whatever I want. Same thing with transitions too. I believe if we actually go look at one of these transitions, like for example, got target. I also have a rate in here that determines how often this transition is evaluated. So this one gets evaluated 3 times per second. If the target's in attack range, 3 times per second, and blah, blah, blah. I can change how often I want to do that, which helps with performance. And these transitions are really simple. They have a single function that just basically determines whether or not we can enter the target state for the particular transition. And this is where you code all your logic and do whatever you want. So for example, if I have a target, I'm just going to check my object if I have a target. If I do, yay. If I don't, nope, can't enter the target state. The path finding's quite straightforward. So for example, with my wander to target, I have a lot of these default functions that I just reuse because they work for the most part. And we're just going to, what this does, it just creates a default path to a target. So I give it the AI object, we get the target, utilities, any information about the AI. So in this case, that's going to be storing our agent parameters, which is important for generating a path. I have this function here, generates a path. It's literally all it does. We have the path finding service. We create a path using these agent parameters. We compute the path, and then we return the path. So when we call generate path, we get that path. Where do we go? Yeah, path to, I guess we could use this one as an example too. So we create the path. We go and we wander to it, and all this is going to do is it's going to go through each waypoints, move the humanoid to it. If we need to jump, we jump, move to it. We time out if we need to. And then I have this custom function here, wait with timeout, that allows me to yield the current running coroutine. And if the signal doesn't fire within my timeout duration, then it indicates whether or not we timed out. If we want to look at the implementation for this, what this does is we get the current running coroutine, store it in the thread variable. We're given the event here, and we're just going to listen once for the event. And at the same time, we're also delaying a thread here. So either this function or this function right here is going to run first. Whichever one runs first is what resumes this thread, because down here we yield. So we pause the current thread, and then either this or this is going to run. And then to make sure that not both of them executes, obviously we're storing the connection here. So if one of them runs, we disconnect the connection and then set the variable to nil, and that's why we check here. If there is no connection, we obviously know it was already ran, so we just return and do nothing. But if the event fired, then we can resume that thread and say, nope, we didn't time out. Otherwise, if we did time out, then we can resume the thread and pass true here, and that's what this function will return, true or false. As well as potentially any other additional arguments with the event if it gets fired. Obviously, there's a lot of code going on here. I'm not going to be able to explain all of it because I'll be here for, I don't know, a century or something. But hopefully this points you in the general right direction of how this AI is working. It's just state machines, different states, transitioning between states, and we're just running logic intermittently to figure out what state we need to go into. Now, the next question we have is, what open source modules do I use? And I use several of them because they're very stinking useful. And I'm going to link a lot of these in the description below. So here I have a list of several useful ones. The first one here obviously is this RbxUtil made by Slightnick, which has a bunch of useful stuff in it. For example, troves, I use this all of the time, super useful. I also use type remote because I like type annotated remote events and stuff. That's pretty useful. There's also other useful stuff in here like his signal implementation, though I recommend LemonSignal, which is what we'll look at in a second. We obviously have his popular shake module for camera shakes and other type of shaking stuff. And there's just other useful stuff in here, like if you want to work with quaternions and stuff like that. I definitely recommend checking this out. See if you can find anything useful you want to throw into some kind of module group you got or whatever. Another useful one's the NevermoreEngine. This thing is filled with a ton of stuff. utilities, custom things, you name it. There's a crap ton of stuff in here. I have a lot of stuff that I use that was pulled out of the NevermoreEngine. Like there's a Spring implementation, I believe, in here somewhere. I believe there's also an Octree implementation in here. Yeah, Octree. There's a whole bunch of stuff in here. Just look through here. There's also Made and stuff like that. It's another cleanup module. Just tons of stuff. You just need to go here, look, see if there's anything useful. Be like, yeah, I want that in my game. If you want it in your game, then you can just click something. So like you click it, be like, oh, here's a useful debug drawing library. I want this. How do I get it? Well, you can just hit this code symbol here. It'll take you straight to the GitHub page. Here's all the code. Copy the code, throw it in a module script, whatever. Some of this actually might require some certain things, like other things within Nevermore, that you might actually need to also find and copy and structure your modules in a certain way. But you can kind of just sit here and nitpick at what you want. And yeah, tons of useful stuff in here. Another one's LemonSignal, a faster and more equipped pure luau signal. This is just the one I use. You could use other implementations of Signal Library, it doesn't really matter. But this one just boasts thread recycling and speed increases, and you can reconnect signals, and it's just kind of cool. This one will be linked in the description. Another thing I use is T, which is a Runtime Typechecker. This makes type checking super easy during runtime, super straight to the point, straightforward, especially when you need to validate data coming from the client to the server and you want to make sure the client actually gave you correct stuff. This is the perfect library for doing that. There's a ton of functions in here. You can pass functions to other functions. You can make interfaces and all sorts of neat stuff. Definitely recommend checking out this one. Another useful one, ZonePlus. Obviously, I'm sure a lot of you have heard of this one. Constructing zones where you can listen to when things enter and exit the zones. That's what the water parts in my game use for summoning water particle effects, that kind of stuff. Very useful module, link in the description. I also use FastCast, so I'm sure a lot of people have heard FastCast. A lot of people use these for guns and whatnot, and I also use this for the projectiles in my game. Super useful module, definitely recommend using this one. For visual, spicing up the visuals in your game, WindShake is a great option for adding like cool shaking foliage in your game. It looks dope, great for environments, and it's very performant. This will be linked in the description. Another one I use, this one actually came out quite recently, is Sera. So this one's pretty cool because it basically gives you the ability to customize or compress data and then send that data through remotes while keeping dictionary schematics. So like you get to keep the keys, you create a schema, and then you serialize data into it using this schema, and then you're given a buffer, and then on the receiving end, wherever, you get to deserialize it using that same schema, and then it's just basically a way for you to transfer data over the network, but compressed. Kind of cool, useful in the library. I'm gonna make a video about this on the future on buffers and stuff like that, so this will also be linked in the description. Another useful page is this GitHub post. This GitHub post has a whole bunch of stuff listed in here of useful things. Like tons and tons of stuff in here. I totally recommend also checking out this GitHub post because you might find some useful stuff in here that you want to use in your projects. Tons of stuff in here. And then when it comes to like styling your code or like good programming practices, obviously the official Roblox Lua style guide is something you want to take a look at, as well as this other cool little concise post found on GitHub of basically 12 rules to follow when you're writing code. So these are definitely useful as well. Another question I got is how are the sounds structured in the game? And they're structured quite simply. I don't have a lot of sound instances in the game except for like music. Most of the sounds in my game are actually stored as code and not sound instances, and then I create the sound instances during runtime, and I clean up the sound instances when I don't need them anymore. I have this sound group down here, my master sound group with some child sound groups for like interface sound effects, music sound effects. So that way you can create a settings page like you saw earlier in the video where you can control like the master volume, which will reduce volume across all these sound groups because these are children of the master sound group. And you can also adjust the volume of these individual sound groups. And then I have inside of my function utils, which is just a module script that just contains a whole bunch of useful functions, function utils. if I go to, I believe it's, I don't know if it's object or it's probably game. Is it in here? Create sound? Yeah, create sound. I have a bunch of these sound functions in here, like creating a sound, playing a sound clone, playing a sound while it follows a part, plays a sound in the world somewhere, playing just a regular sound, playing a random sound, playing a random sound clone from an array of sounds. These are the sound functions I use anytime I want to play sound in my game. So these handle everything. They handle the cleanup. It just makes it super simple. I want to play a sound. I just give all the properties I want for the sound. It creates the sound, places it where it needs to go, plays it, and then that's it. Cleans it up once I don't need to use it anymore. Someone else asked, how am I listening to client inputs? And I believe I have like a client input, or like an input service somewhere. I made this a while ago, so you might need to forgive me. Client control? It might be client control service? Yeah, I think it's this. How am I doing it? Context action service. Oh, I wrote this like a year ago. Yeah, this is a while ago. You want to use client input? Context action service is the absolute way to go. And this custom service I made is really just serving as like an abstraction over context action service specifically for my game. So like I have some specific functions in here to like halt all combat controls or resume combat controls or halt specific controls. And then if I want to bind or unbind my controls. And then I just have some signals in here that I literally fire for specific things that happen. And then elsewhere in my code, I just listen to these signals and then perform certain actions. This is kind of a weird way I did it. I don't remember exactly why I did it this way, but I wrote this over a year ago, so I can't really tell you what I was thinking a year ago. But yes, you want to use the context action service when you're using controls because it makes it super easy for mobile controls, listening for input across all different game platforms, whether you're on console, PC, whatever. And then it makes it super easy to unbind those actions when you don't need them anymore. Context action service, use it. Someone else asked, how are the hitboxes being done? Great question. And that kind of also ties into another question somebody else asked is how the skills or the entity skills are being handled. So I have a skills catalog. I think it's called skill. Is it called skill catalog? Skill catalog. And this stores all of the functionality for skills in the game for my survivors, for the enemies. So as an example, with my good old survivor or guardian here, Roblox, I kind of have them organized into their different modules. So if I want to use my sword throw skill, right? All of these are structured based on a type that I have defined somewhere. Yes, info types. In this module, I have a bunch of types in here, and I have this skill info. Anytime I need to make a skill, it needs to follow this format here. It needs to have a name, what type of skill it is. So is it like primary, special, utility skill, whatever. Proc coefficient, if any non-combat skills have a proc coefficient of 0. Cooldown, default playback speed, bunch of other stuff in here, and then an enter and exit function. So what functionality happens when you enter into the skill? What functionality happens when you exit the skill? So specifically with the sword throw, on the client side, I have a entity skill class. I use this to construct my skills, and this stores a bunch of signals in here that are super helpful. And then I think there's like an attempt or enter. Gosh, I'm not memorizing. You can tell that I don't memorize because I don't need to memorize. Attempt. Yes, I attempt to enter a skill. We attempt to do a skill. And this is just what goes through and runs all the code for the skill. This class serves as an abstraction over the data being stored in the skill catalog. So it just goes in here and it executes my onEnter function. So it gives me the entity which is executing the skill. And you're going to see there's some other extra information here. Replicate callback, extra data, replicate args. This replicate callback is only going to exist on the client or in the case of the AI being controlled by the server. On the server side, this callback is only going to exist for the person who is actually performing the skill. And then these replicate arguments are going to only exist for any other player in the game that needs to replicate visually the skill, because I have nothing visualized on the server. So if I'm the person, let's say I'm the client performing this skill. So basically this is where it happens down here. I want to yaw my local character, rotate my character in the direction of where I want to throw my sword. I play an animation. I adjust the animation speed to make sure it matches my attack speed, whatever that is. And then whenever I hit this throw event inside of my animation, This is when I call my replicate callback to tell all the clients in my game, hey, I want you to run this on enter function. And this is where I throw the sword, which is right here. Create a raycast, use FastCast, I fire a FastCast, and then this caster up here is what handles all the visual stuff, and then the hit, like ray pierce, ray hit, that kind of stuff. But if another client who did not perform the skill is simply replicating it, I do that check right here. I don't do any of the other fancy stuff down here. I simply just throw the sword based on what the current target position and the origin is from those replicate arguments. Throw the sword, does the exact same thing here. I also store inside of this cast if it's replicated. So that way inside of this logic up here, I know whether or not I need to execute functionality simply for visual replication purposes, or if it's not replicated, then this is where I make my damage request if I'm the person performing the attack. And that's going to be for client-sided skills. If we go to the skill catalog again, let's go back. Skill catalog. Let's pick noob, punch. This is going to be a little bit different because the server is going to be executing this on enter function, which happens right here. So if the run service is server, then I know, hey, I need to tell all the clients to visualize this because the server's not going to be doing anything. It literally does nothing. I just tell all the clients in the game, hey, perform this attack. This is your target. And then down here is all the client-sided functionality. So we get the target, make sure everything's good. Client side runs the animation. The client side plays the animation. I literally want nothing happening on the server side. And then the neat thing about doing it this way is because every single client that's in the game is running this function. Whenever I do the hitbox check, because we're doing the hitbox here, I have just this generic hitbox check function in my function utils. So we'll look at that actually real quick. We give it an origin. What's the size of the hitbox? If I have some extra height coverage, where to look at some other extra optional things. But it's literally just a get parts bound in box call. That's all it is. That's my hitbox check. And then I just return that result. And then here is where I just go through all these things and I check to see if my local player, which is another thing in my function utils, if I exist anywhere in this result. And if I do, then I tell the server, hey, I need to damage myself. And I only do it for my local player because every single player in the game is doing their own damage check to see if the attack hit their own local player. And that provides the best user experience because what the server sees may not match what other clients see because every single client has their own downloaded copy of the game and replication. Obviously, there's delays. So it looks best visually if each client does their own hit checks, which is how I have it set up here. And that's basically just kind of how these skills are being done. We enter into it, and then obviously we need a yield for however long this skill happens for. And then when we're done yielding, we exit out of the on enter. That's when we enter into the exit, which just cleans up the trove, and that's kind of it, just ends the skill. The last question I got is how are health and shields handled? That's a good question because I recently had to redo my entity class due to the changes I made with wanting the AI to be handled by the server this time instead of the client side, because obviously there's too many security issues with like network ownership and stuff with the clients handling the AI, as well as just a lot of bandwidth usage. So I decided to restore control back to the server. And then with all the skills and everything that visualized, the server tells all the clients to visualize that stuff. So it still looks pretty smooth. But health and shield are handled by my entity class. This is, I don't know if you want to call this like my custom humanoid class. It really isn't because I'm not doing any physics stuff in here. This is purely storing properties. So I have my health stored in here. What I do is, let me see if I can find it. I construct my new entity. My entities have a bunch of signals like if the level changes, gained XP, lost XP, combat state change, sprint state. If I'm low health, I reach full health. Bunch of cool signals that I use across my games for my entities. I should have health stored in here somewhere. I can't remember where I'm storing this health. Yes, so my entities are represented by these configuration instances. So let's find an example entity instance. Here it is. And this is how my entities are represented in my game. Is literally just a configuration that stores data so clients can read from it. And this configuration stores things like if it's currently dead, what the current AI state is, the name of this entity, blah, blah, blah. And then this stats section is where all these stats for the entity is stored, like what's their luck, what's their level, their shield, and their health is also stored in here, like their current health, current shield. This is where the values are read from. So on the client side, I can literally just listen to when these configuration instances get added into, I believe it's going to be loaded map. So they get parented under enemies or guardians. So I can just listen for when things are added or removed to these folders, get those configuration instances, listen for when these properties changes if I need to do anything like that. And then this entity class is what's responsible for updating these read values. Now my entity class is obviously using a little bit of composition, because what I do is I have a bunch of other classes. Yes, I have my managers. These are like components, just to make sure my entity class isn't like thousands of lines long. I split up some of the other functionalities for my entities into different manager classes. So like handling effects on entities, that's this guy's responsibility. Handling items in my game, handling rewards when an entity dies, handling their skills, handling their state, and handling their stats. They all get segregated into their different managers, and then in here I construct all my managers. I throw it on my inside of my entity as a property right here. Whole bunch of other listeners I set up in here to do things like handling item events for my item manager, firing signals, updating there's just a lot of stuff going on. I spent way too much time on this, but hey, it makes a cool game. So, and then I have some other useful functions in the class. So these are all class methods. So I get all the entities that can regen, get all the alive player entities, get player entities, and then all the methods that belong to the entity objects themselves are stored in the meta table. So like if I want to kill them, revive them, set states, give shields, give health, change combat states, set levels, give XP, give ticks, all this stuff is in here. Tons of stuff is going on. But that is kind of how I am handling shield and health in my entity class. And then I just read it off of the configuration instance. Obviously, since the last devlog, there's been some additions. Like you can tell there's this terrain here because the Meat Meadows map, the first map in the game, got remade, and I'll show that to you. So let's hop into a quick playtest. So here we are. This is the new Meat Meadows map. It's very, very big, but it's kind of pretty. My fellow developer had a fun time making it. It looks pretty good. Yeah, it's a neat big map. You get to explore around. There's some caverns we get to go into to look around for stuff. Very big map, very cool map. Just to make this not too slow, I'm just gonna give myself a bunch of those so I can move faster. The teleporter's over there. But yeah, this is the new map. Looks pretty cool. There's a lot of flowers all over the place. Very pretty. We got a nice waterfall. We got these cool pillars going over the map. We got some mountains in the background, I believe. Yeah, we got some mountains out in the distance. Looks cool. Oh shoot, I fell. And then I also coded a new boss enemy. I have no idea if he's going to show up on this event. Nah, it's the buff noob. Okay, I'm just gonna kill him. The new enemy, let me summon him. Actually, before I summon him, let me give myself a bunch of these so I don't die. And then let me summon the Magma Fiend. Here he is. Ooh, yeah, that's what he does. He throws rocks at you. If you get too close to him, he explodes with a bunch of lava rock stuff. And yeah, this is the enemy, you know? Kind of just hangs around. Smashes these things in the ground. These things burn you. They hurt. You don't want to stand in them. This explosion pushes you back. Pillars coming at you. He was a fun enemy to make. He can throw rocks at you and whatnot. So, whoa, why is there a rig here? I guess we've got to remove that. But yeah, kind of a formidable boss enemy. Obviously, when you're in a boss fight, you got a bunch of other entities attacking you. He's kind of a little bit tough to fight. And he has quite a bit of health, too. So, yeah, he was fun to make. We also remade another map, which is the Arctic Alpine map. So this is a new wintry map we remade. Or my other developer, he's the one who made the map. I'm not the one who built the map. This is the new wintry map. Very cool, eerie, spooky looking. We got some caverns in here, lots of snow, snowy trees and stuff. You explore around the map and whatnot. Looks like a teleporter spawn over here. We got a nice frozen lake, frozen waterfall back there. Yeah, you can tell we like waterfalls. It's kind of just a cool, nice, wintry map to explore. We'll probably also be remaking the desert map. There's obviously going to be a couple new maps as well. On release, I want there to be at least 5 maps for like the open, alpha or open beta or whatever we're going to be doing. And otherwise, I think that's about it. Obviously, there was changes to the lobby that you saw earlier. But right now, we're just kind of focusing on adding content. Got to get a couple more survivors in the game, definitely more enemies, more maps, and get things done in the lobby. And hopefully soon, we should get a nice open, testing version out for people to play, which will be really, really cool. Otherwise, thanks for sticking around for this devlog. If you have any more questions, of course, please leave them in the comments. I'll be reading them, and I'll probably answer them on the next devlog, whenever that is. Otherwise, thank you for watching. I will see you next time.